Hello, this is John Clark, and I'm going to go through Assignment 1002 Crymland Analysis. I'm going to start out by running the code. Okay, you can see this is an example of where crime grew out of control in Crymland. You can see that the number of thieves went up to 7, but the number of individuals in the syndicate grew up to 60,000 people. Mr. Big's wealth is up to about 1.5 billion and total bribes. So not much there until we hit somewhere around week 51, 52, where we jump up to 4 million, which is still a very small number compared to how the syndicate is doing. So it's just jumping into the code. I have two functions, get input and time series charts. Get input simply has two statements, the first of which reads the data file, which has no headers in it. A second statement then adds the headers to the data frame. The data frame is then returned back to the calling function. Time series charts takes in the data frame, and the first thing it does is it creates a figure with 2x2 subplots. I also increase the figure size to get the 4 graphs to show up properly so there's enough space. Then I first plot the graph and then add a title for each subplot. After that is done, I save the figure that I just built to a file and then finally show the subplot. As to the time series plots and talking through those, I am going to jump to the report. This is very similar to the graph or set of graphs that I just showed. Here, the number of thieves that are jailed consistently increases, but it's dwarfed by the growth in the number of thieves that have not been put in jail. Mr. Big's wealth experiences very similar exponential growth up to 1.4 billion by the end of the simulation. The bribes total just over 2 million, which is something but nothing compared to the crime the syndicate's bringing in. Let's go to another graph, and this is where crime is shut down. And this has exactly the same input parameters, by the way. Mr. Big was arrested and put in jail after 4 weeks. This was a case where 3 thieves were caught, and then because of that, the fact they worked for Mr. Big was also jailed. There were no bribes. 1 person had been caught in the first week, and then the number of people in the syndicate steadily declined until Mr. Big was caught and the simulation ended. Just answering the last question, overall, I ran a lot of iterations of this program in different forms with different values for the input parameters. What I found is there seemed to be an inflection point, and either the syndicate got shut down or it completely grew out of control. I found that the 2 most important variables that either increased the success of Mr. Big or led to his rapid arrest were the values of solve init and solve cap. If I put solve init at 0.01 and solve cap at 0.05, crime would grow out of control every single time. If I put solve init at 0.5 and solve cap at 0.9, I could shut down the growth every time. The analogies to a pandemic, which we're obviously in right now, are really kind of striking to me. With solve init being somewhat similar to immunity that a population might have, such as individuals in China during the 1918 flu, because they had experienced a previous strain which was much less deadly, so they didn't have nearly as much of a problem as other countries. And then the solve cap is sort of analogous to a vaccine, which is developed over time. So I thought that was very interesting. So that's basically it. End of video.